Hi everyone, I'm going to discuss group min. So last time we learned about measures of central tendency involving ungrouped data. So today we will be working on calculating for the group min. So we're going to consider these examples. So the following data represents the ages of 30 high school teachers. And we're going to construct 5 class intervals, complete the table, and calculate the group min. So we're going to complete the table here. And now a group data is made up of class interval. So when we say class interval, this consists of lower and upper limits. And and each score here or value is assigned to each class interval. So meaning each age here, for instance, is represented by a class interval. So we need to complete the table here for us to calculate the group min. And constructing the class interval requires us to identify the class size of each interval. So I is the class size or width of each class interval, and the class size must be the same with any of the, for example here, 5 class intervals. So calculating the class size is obtained by working on the difference between the highest value and the lowest value. So we have 58 minus 21 divided by the number of class intervals. So in this exercise, we are asked to construct 5 class interval. So we're going to work on the difference between 58 and 29 and divide that by 5. And this is equal to 7.4. Now we'll round up the value, so that gives us 8. So the class size is 8. So how do we construct the class interval with that information? So the first lower limit class is the lowest value, which is 21. And we will add the class size to the lower limit minus 1, because we already have one element here, 21. So whatever the value of I, which is 8 here, we will less that by 1. So we will add 7 to 21. So we have 28. So we have the first class interval. So why we less 1? Because 21 is part already. So this is 1 and then plus 7. So 21 to 28. To obtain the next class interval, we will add 1 to 28 and then add 7 again. So this is 36 plus 1 to 36 to obtain the next lower limit, and then plus 7. So this is 43. Okay, so 29 plus 7 is 36, and then 37 plus 7 again is 44 rather, and then plus 1, and then plus 7. So this is 52 plus 1, this is 53, and then plus 7 again, 60. So the lowest value should be in the first, within the first class interval, and it should be the first lower limit, while the highest value should be within the last class interval. Not necessarily the highest value must be the upper limit. Okay, so the these values class are the lower limit, and this one as the upper limit. And this is the composition of the class interval, the lower limit and the upper limit. So the next thing that we're going to do is to tabulate each observation here and count how many values will fall on each class. Like how many values will fall from 21 to 28. So we have 1, 2, so this is 2, And then how many values will fall from 29 to 36? So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 here. And then how many values will fall from 37 to 44? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10. Then how many values will fall from 45 to 52? So 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. And then we have 2 from the last class interval. Now, take note, class, that the total frequency must be equal to n. And your n is 30 because there are 30 scores here, values, observations. Okay? So, n is 30, or the sum of f is n. And then the midpoint is, or the midpoint, which is represented by x, is the average between the lower limit and the upper limit. So this is divided by 2. Solving for the midpoint of the first class interval, this is 21 plus 28 all over 2. So 21 plus 28 divided by 2 is 24.5. So the midpoint here is 24.5. Now, we don't need to do the same way as what we did in the first to solve for the midpoint. Now, since the size of the class interval is constant, what we will just do is add cumulatively whatever the value of I, which is 8 here. So, 24 plus 8 is 32.5, plus 8 is 40.5, plus 8 again is 48.5, and then plus 8 again is 56.5. Now, you can also do work on the average of 29 and 36, and really the value is 32.5. And then fx would mean multiplying the frequency and the midpoint. So what is 2 times 24.5? So place it on the last column. What is 8 times 32.5? So it's 260. What is 10 times 40.5? So this is 405. And what is 8 again times 48.5? So this is 388. And last, what is 2 times 56.5? This is point 0.5, class. So we have 113. Now work on the total of fx, because calculating the mean would require us to work on the sum of fx. So this is adding all the values on the last column, and then divided by n, which is 30. So 49 plus 260 plus 405 plus 388 plus 113 equals 1215 divided by 30. So this gives us 40.5. So this is the average age of the 30 high school teachers. So from the data, less than 40.5 would mean, so age which is less than 40.5 among the 30 teachers there would mean a younger age. And then greater than the average age would mean an older age. So that's how we interpret the group mean. So let's have another example. So the following data represents the electricity consumption of 30 households. Construct 5 class intervals. Complete the table as what we did in the first example and calculate the group mean here. So we have to work on I, and I is, this should be 3498, the last value. This has to be 3498, okay? So solving for I is working on the difference between 3498, which is the highest value, minus the lowest value, divided by 5, since we are going again to construct 5 classes. And 3498 minus 1001 equals 2497 divided by 5 and round up the value. So this gives us 499.4. So meaning I is 500. So we will now construct the class interval, and the lowest is 1001. So 1001 and then plus 500 minus 1. So this is 1001 plus 499 is 15 plus 1. So this is 1501 plus 499. So this is 2000. And then this is plus 1. So this is 2001 plus 499. So this is 2500. And then plus 1. So this is 2501 plus 499. So this is 3000 plus 1. This is 3001 plus 499. So this is 3,500. So we're going to tabulate as what we did in the first example. So how many values will fall on the first class? So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 here. How about from 1,501 to 2,000? 1, 2, 3, 4, 5. And then 2001 to 2005. So 1, 2, 3, 2,501 to 3,000. So 1, 2. And then the last value. So we have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So a total of 30 here. Now the midpoint again is equal to 1,001 plus 1,500 divided by 2. So this is 1,001 plus 1,500 divided by 2. So it's 1,250.5. So we will not do the same process there. We will just add 500, which is the I. So this is 12750.5 plus 500. This is 2250.5 plus 500. This is 2750.5 plus 500 again. This is 3250.5. And then we will multiply f and x. So everything here is multiplication. So 8 times 1250.5 is 10,004. Well, 5 times 12,270.50.5 is 8,752.5. 3 times 2,250.5 is 6,751.5. And then 2 times 2,750.5 is 5,501. While 12 times 3,250.5 is 39,006. And then we're going to work on the sum of fx here, since this is needed in calculating for the mean. And this is equal to 7015. So working on the mean is working on the summation of fx over n. And sum of fx is 7015 divided by 30. So the mean here is 2,233.83. So this is the average electric consumption of 30 household. So in our next discussion, we will be working on the group median. So I hope you are able to understand the discussion. So bye for now.